So let's start off by taking a look at this airplane that's traveling in a uniform circular motion in the horizontal plane. At one point the airplane is over here, at another point it's over here, and it's always accelerating towards the center of that circle. So what we're going to do is we're going to pause this video really quickly and let's just see if we can, let's see if I can pause it right about there. Okay, so from this point, let's see if we can draw a free body diagram of the airplane from your frame of reference. So what we're going to do is draw a little box to represent the airplane, and let's draw the forces of gravity acting down. So we have a force of gravity acting down. We know that force of gravity is also equal to mass times gravitational field, so let's write that in there. You can see that there's a force of tension acting in this direction. Okay, so let's label that as F with a subscript T. And I think most of you can recognize that it is at approximately 52.5 degree angle away from the vertical, that is. So let's just draw an imaginary vertical line, and I'll label this angle in here as approximately 52.5 degrees. Okay, I think most of you can see that from this frame of reference, if it is in fact accelerating towards the center of the circle, which is approximately there, we can actually break down this force of tension into x and y components. So how do you break this down into x and y components? Well, there in green I've drawn my force of tension in the y plane, and you can see that I've drawn my force of tension in the x plane as well. So just to make things a little bit clearer, let's just see if I can get rid of this, get rid of that image in the background. Let's move everything over this way, and let's start by labeling a couple of things. So I'm going to label this force over here as my force of tension in the y plane. We'll label this as force of tension in the x plane, and I think most of you can see that we have a right angled triangle all of a sudden at the very top there. Now, if you take a look at this airplane, it's not accelerating in the y plane, which means it's not accelerating up and it's not accelerating down. And we only have these two forces in the y plane. And since the sum of these two forces must be equal to 0, we have to say that the force of tension in the y plane must also be equal to, in magnitude, 2mg. Okay? So what we have with respect to that 52.5 degree angle all of a sudden is the adjacent side, and we're actually looking for that opposite side there. So how do you go about finding that opposite side? Well, if you take a look, what we're going to do now is see if we can find the 10. Oops, let's see if we can find the 10 of that 52.5 degree angle. We know that the tangent of any angle is going to be equal to the opposite side, which in this case is ftx, over the adjacent side, which in this case is fty, but we know that to be mg. And if I isolate for ftx, that gives me mg times 10, not 1035, 10, let's erase that, 10, 52.5 degrees. Okay. Now we also know for a fact that this airplane is accelerating towards the center of the circle, and we can now say that anything that accelerates must follow Newton's second law of motion, which is the net force, or in this case the centripetal force, over mass. So we know in this case that the centripetal force is equal to the net force over mass, and the net force, where's the net force over here? The net force over here has to be equal to the forces that are acting towards the center minus the forces acting away. In this case, there's only one force acting towards the center, which is ftx. So I'm going to say that centripetal acceleration has to be equal to mg 52.5 divided by m. Most of you can see that the masses can now cancel out, which just leaves you with g times 52.5. And that's it. And that's how you would find the centripetal acceleration for an airplane traveling in a uniform circular motion in the horizontal plane. The one thing you have to keep in mind, though, is that this centripetal acceleration, now you have to ask yourself, well, What are you going to make this equal to? Well, you know that it could be equal to v squared over r. It could be equal to 4 pi squared r divided by period squared, or it could be equal to 4 pi squared r frequency squared. Which one do you use? Well, it all depends on whether you are asked to find, or if you need to use the speed of the airplane, the period of the airplane, or the frequency of the airplane. Okay? Now, how do you take a question like this and use it for things that are not airplanes? So if I take a page over here, now I'm going to deal with objects that generally cars or any vehicle traveling along a circular path on a banked curve. So if you take a look at this question over here, it's similar. It's relating to the question that we did in class, where you have a car traveling in a circle at some kind of an incline. So it says here, determine the maximum speed. Let's circle a couple of things here. So they want you to find the speed a car of unknown mass would have to be traveling at on a frictionless banked curve in order to demonstrate uniform circular motion. So to deal with this kind of a question, we're going to see if we can draw the picture from a bird's eye view first. Okay, so let's say that that's the circular track. Here's the car, and the car is traveling in a uniform circular motion. Obviously, it's going to be experiencing some kind of a net force or a net centripetal force towards the center. Now, it's hard to see exactly what that force is unless you draw this from a rear view. So if you had to draw the rear view of the car, it may look something like this. Okay, so there's the incline. You have a 35-degree angle. Okay, so let's draw the car. And now let's draw the forces that are acting on the car in this rear view. Most of you can see that we do have a force of gravity acting down this way. Once again, this has to be equal to m times g, the gravitational field. I think you can all see that there's also a normal force acting this way. We'll label that as Fn. Okay, and since the center of the circular path is over here, you can see that it is, of course, accelerating towards that center. Now, what can I do with this normal force? Well, let's just see if I can bring this down a little bit here. Okay, so if you take a look at this normal force, what we're going to do now is, again, break it down into x and y components. So if I take a look, this would be my normal force in the y plane. This would be my normal force in the x plane. Okay, so what do you label this angle down here to be? If you take a look at this angle, it's actually identical to the angle that you have down here, so we're going to label that to be 35 degrees as well. Okay, so from this point on, just like we did with the previous question, oops, we can't do that. Let me just move this over. This is not working very well. I don't know why. It doesn't matter. Let's move this over like so. Okay, so if you take a look at the free body diagram now, once again, very similar to the airplane, I think you can see that this normal force in the y plane and this force of gravity have to balance each other out. So once again, I'm going to say that F and y has to be equal to mg. Okay, so if I take a look at the normal force in the x plane, we're going to say that the normal force in the x plane is once again opposite to that 35-degree angle, which means it too must end up being equal to mg times 10 35. Okay, and since this car is accelerating towards the center of that path, we're going to say that the centripetal acceleration has to be equal to the net force, or in this case, the centripetal force over mass. And we know for a fact that the centripetal force is the only force that's responsible for the centripetal force is this normal force in the x-plane. So let's plug that in. We have mg 10 35, and all that divided by m. Once again, the masses cancel out, and you can see that we are now left with the centripetal acceleration just being equal to g 10 35. So whatever 9.8 times 10 to 35 turns out to be equal to, that gives you your magnitude for that centripetal acceleration. And once again, you have to ask yourself, well, what are the three different things that this can be equal to? Depending on what you're being asked to find, you might want to use either, again, v squared over r, or you might want to use 4 pi squared r divided by period squared, or you can use 4 pi squared r times frequency squared. Class, sorry for the messy handwriting, but hopefully I was able to clarify some of this stuff for you. In any case, good luck today. The only thing I want you guys to do for homework is, of course, work on that review package. Hopefully with the stuff that we went over today, you should be able to now go over bullet number 14 in a bit more detail. And of course, I want you to finish off bullet 15 as well in preparation for your unit test coming up. So if you have any questions, please post on Edmodo or or talk to me on Monday. Okay, thanks.